Dear student, today we will be discussing on the rest of the aspects regarding factors affecting corrosion rates. They are actually humidity of air, impurities in atmosphere and conductivity, suspended particle ions and electrochemical potential. And let us start with humidity of air. Perhaps all of you know that critical humidity is the relative humidity above which rate of corrosion increases drastically. And critical humidity depends on physical characteristic property of metal and nature of the corrosion product. The rapid change in corrosion rate in humid condition are mainly because of some gases like carbon dioxide, oxygen, water vapor, which helps to develop an electrochemical cell. Moreover, there are many oxide layers on the metallic surface which may have the property to absorb moisture and therefore makes an electrochemical cell, as a result of which rate of corrosion increases. Rainwater, other than actually making an electrochemical cell, wash away good part of the oxide layer and exposing the metallic structure for further rapid attack unless oxide layer is very tightly adhered on the metal structure, as in the case of aluminum and chromium. This is all about your actually impurities of air. Now let us see the second point, that is impurity and conductivity. Impurities and conductivities. This is very, very important issue. All of you know that environment in the vicinity of chemical industry in particular may contain industrial gases like carbon dioxide, sulfur dioxide, hydrogen sulfide, and in addition to that, fumes of hydrochloric acid, sulfuric acid. As all of us know that this kind of gases and fumes will make your environment, in particular water adjacent to the metallic structure, acidic, as a result of which electrical conductivity will get increased, resulting higher rate of. Now let us talk about the third point, that is suspended particle. This suspended particle may be of two types. Number one is active and number two is inactive. If your environment contains suspended particle, active suspended particle like sodium chloride, ammonium sulfate, they may absorb moisture and they will being very active electrolyte, rate of corrosion will increase. But in case your suspended particle is inactive in nature, as in the case of charcoal, they will absorb sulfur gases in particular and moisture, reducing the rate of corrosion. And therefore, in brief, we can tell that if the suspended particle is active in nature, rate of corrosion is expected to increase during their presence. And if the suspended particle is inactive in nature, in case of charcoal we have seen, rate of corrosion will decrease. Next point is your ions. This is very important parameters. If ion available in the environment is such that it makes compound which is insoluble in nature, as in the case of silica gel. So it will actually deposit on the metal surface, and during which the rate of reaction will automatically go down. But in case of chloride ion, as in the case of seawater, as we have seen earlier also, chloride ion, if present, it will damage the oxide layer, as a result of which rate of corrosion is drastically increased. And therefore, in this situation, we can say that if iron is capable of producing insoluble compound, then they will reduce the rate of corrosion, or otherwise it will initiate the reaction. And last point is our electrochemical potential. electrochemical potential. As all of us know that every metal gets or takes away some electrochemical potential when it is immersed in a conducting medium, and this is known as half cell potential, as this potential can be measured by comparing it with a reference potential produced by reference electrode. All of us know about it. Most commonly used reference electrode are calomel electrode, silver chloride electrode, copper sulfate electrode. The potential takes away by the metal will determine whether there will be any kind of change in the corrosion rate. This potential can be changed either by connecting it to a dissimilar metal or by applying external potential. Keep cathodic protection system commonly employed on the external hull. Here I would like to tell you the hull is actually the watertight enclosure of a ship. Watertight enclosure of a ship which will protect the cargo machineries and accommodation space from natural calamities like flooding and other structural damage. These are all about the factors affecting by influencing the rate of corrosion. I hope you might have understood. Please go through the video very carefully. If there is any confusion or doubt, please get it noted. We will clarify it in the next meeting. Thank you very much.